Very good morning. Today I'm going to explain you about oxidation reactions of benzene. Oxidation reaction, oxidation reaction and addition reactions of benzene, and even nomenclature of benzene, how we name the benzene derivatives. The objectives of today's class: at the end of the class, students able to explain the addition reactions of benzene, oxidation reactions of benzene with the predicted mechanism. They're able to predict their mechanisms, whether it addition reactions or oxidation reactions. Students able to name different benzene derivatives and write the structure based on the names. Addition reactions: basically benzene undergoes electrophilic substitution reactions at normal conditions, but benzene undergoes addition reactions at high temperature and pressure. So benzene undergoes addition reaction with hydrogen and halogens. We'll see addition of hydrogen. When benzene reacts with the hydrogen in the presence of catalyst, here the catalyst is very important, that is nickel or platinum at high temperature, that is 150 degrees centigrade, under pressure, it forms cycloalkanes. So hydrogen has been added to the benzene. All the double bonds are converted to single bonds, such that 6 hydrogens have been added to the benzene to form a cycloalkanes. Benzene, we have a 3 double bonds here. When it is reacted with 3 moles of hydrogen in the presence of nickel, a catalyst, in the presence of high temperature and pressure, that is 150 degrees centigrade, all the pi bonds are converted to single bonds. The hydrogens have been added here against the double bonds to form cyclohexane. Addition of halogens. Um, Benzene reacts with chlorine or bromine in the presence of ultraviolet light, yields benzene hexachloride or hexachlorocyclohexane. So this is hexachlorobenzene or benzene hexachloride. It is acting as an insecticide. So when benzene reacts with 3 moles of chlorine molecule or bromine molecule in the presence of UV light, it gives the chlorine atom is attached to all the 6 carbons to form benzene hexachloride, or BHC, we called as, or hexachlorocyclohexane. This molecule is acting as a insecticide, powerful insecticide called as gemaxine. It is being sold in the name of, trade name of, gemaxine. So if you see the mechanism of action, these two reactions, that is addition of hydrogen or addition of halogens, will follow the free radical mechanism. It involves a free radical mechanism. The chlorine molecule Cl2, when it is exposed to the UV light, it undergoes homolytic fission. Homolytic fission means sharing of electrons equally. So we know that 2 electrons are being shared between 2 chlorine atoms. These 2 electrons will be shared equally. 1 electron is taken by this chlorine atom, another electron is taken by this chlorine atom, with the fission, homolytic fission in the presence of UV light, to form chlorine free radical, chlorine free radical. Once a chlorine free radical which is formed will be very reactive, will attack the benzene. So when benzene reacts with the chlorine free radical, the chlorine free radical is being attacked here. When it is attacking the benzene, benzene pi bond breaks, it undergoes homolytic fission, 1 electron from benzene and other electron from chlorine to form a CCl bond. So the electron which is left will shift to the next carbon atom and it forms a free radical. Benzene chloro free radical is formed. This free radical, which is very reactive, will try to react with another chlorine free radical. This chlorine free radical, the benzene free radical, takes this chlorine free radical to form a dichlorobenzene. So this reaction is not restricted to single step, because you have two more double bonds. So when they undergo chain propagation, we know that free radical mechanism, always there is a propagation, there is a formation of free radical, there is a propagation of free radical, there is a termination of free radicals takes place. So here these two double bonds will undergo similar type of reactions. So chain propagation takes place and it gives rise to benzene hexachloride. So all the 3 moles of chlorine, here we have seen only 1 mole of chlorine, but it undergoes 3 moles of chlorine, undergoes similar type of reaction, free radical mechanism, and it forms, all the 6 chlorine atoms are attached to the 6 carbons to form benzene hexachloride, which is called as a gemexin, which is a powerful anti-insecticide or insecticide. So similarly, hydrogenation takes place in the same mechanism, free radical alkylation, free radical hydrogenation or halogenation. Next reaction we call as oxidation reaction. Benzene undergoes oxidation in the presence of a catalyst. So benzene, when it reacts with ozone, that is O3, it gives rise to triozonide, which upon treatment with zinc in the presence of H2O, it yields glyaxol. So benzene undergoes ozonolysis also. When benzene reacts with ozone, that is 3 moles of ozone, it forms a triazonide. Each 5-member ring with 3 oxygen we call as melazonide. We have 3, we call as 3 melazonides will try to form triazonide. This is very, very unstable. This triazonide which is formed will undergo breakage, will undergo lysis, will undergo breakage, because this is triazonide is very, very unstable. So it undergoes breakage like this. So it breaks here, it breaks here, similarly here, here, and here, here. It undergoes lysis, and in the presence of zinc, water reduction takes place, means this oxygen which is there here, one single oxygen between this ozonide will form water. Water is removed. So to form glyaxol, means this becomes a ketone and CH and ketone. So glyaxol, 3 moles of glyaxol will form. 1 mole of glyaxol here, 1 mole of glyaxol here, and another mole of glyaxol here. So 3 moles of glyaxol is formed when benzene is reacting with ozone. So it forms first triazonide, which and when we react with zinc in the presence of water, it gives rise to glyaxol. You see the mechanism involved here. We'll talk about one single double bond. So assume that this 1 and 3 are hydrogens in the benzene. 1 and 3 are benzenes, and 2 and 4 are carbons. So this carbon attached to another carbon. So when you assume this double bond which is there, when it is reacting with ozone, this is the structure of ozone, this is resonance stabilized, right? So the negative charge will again form the pi bond here, and this pi bond shifts to this oxygen, form negative charge. This ozone is a resonance stabilized. When it is reacting with one bond of benzene, so there is a chance of attack. So this pi bond take the pair of electron and attack this oxygen. Then this pi bond shifts to the oxygen to form a negative charge. So this negative charge which is there will try to attack here, because this carbon is losing pair of electron. So the simultaneous, so this carbon attacks this oxygen, pi bond shifts to this oxygen, and this negative charge attacks this carbon to form a melazonide. So one melazonide is formed. We have 3 double bonds, 3 melazonides are formed. So 1 and 3 are hydrogens, and 2 and 4 are other carbons of benzene ring. So 3 melazonides are formed. This melazonide, when it is react with zinc and water, it undergoes a decomposition. So when the bond breaks here, when the bond breaks here, this bond breaks here and this oxygen comes here. So cycloreversion takes place to form a ketone form is formed. Ketone form, there's 1 and 2 are hydrogens, aldehyde, and sorry, one is hydrogen and this carbon, and this 3 is hydrogen and this carbon. So there is a 2 and 3 attached to two different ketones. That is the reason we got glyaxol. So we got glyaxol. So if you see, go back to the reaction, this glyaxol, one ketone here and one ketone here will form a glyaxol. So when benzene reacts with ozone in the presence of zinc and water, it yields glyaxol. That is very, very important because triazonide is a very unstable molecule, which when it is treated with zinc and water, the bond breaks, destabilizes, decomposition of triazonide takes place to form glyaxol. Another oxidation reaction we need to talk about is a vapor phase oxidation. So benzene undergoes oxidation in the presence of air or oxygen in the presence of a catalyst called as vanadium pentoxide. Vanadium pentoxide V2O5 at high temperature, that is 450 degrees centigrade, to give maleic anhydride. Benzene, when it is treated with 9 moles of oxygen molecule in the presence of catalyst V2O5 at 450 degrees centigrade, you get oxidation takes place at benzene, and it forms a ketone. Maleic anhydride is formed with the loss of water molecule, 4 moles of water molecule and 4 moles of carbon dioxide is formed. So always vapor phase oxidation takes place in the presence of catalyst. So benzene undergoes oxidation in the presence of vanadium pentoxide at high temperature to form maleic anhydride. This is the reaction we have seen. That is, we have seen addition reactions, we have seen oxidation reactions, addition of hydrogens to give rise to cyclohexane, addition of halogens to give BHC, that is ganaxene, and the oxidation reaction. Benzene undergoes oxidation reaction with ozone to give glyaxol. Benzene undergoes vapor phase oxidation in the presence of catalyst vanadium pentoxide at high temperature to give maleic anhydride. So these are the two different oxidation reactions and addition reactions of benzene. So these two reactions are not possible at normal temperature, but benzene is a very stable molecule. It needs high temperature at drastic conditions to undergo this oxidation reaction or addition reaction. Now we'll discuss about the nomenclature of benzene derivatives. We need to name, because benzene substance are very, very enormous. Different structures are there. We need to name this molecule. The rules for nomenclature of benzene derivatives, first we'll see to name a monosubstituent derivative. Monosubstituent derivative means single substituent derivative. How do you name? We need to name by adding the name of the substituent and as a prefix, and suffix should be the word benzene. If you take the example here the benzene is being attached to the ethyl group, so we call it as ethyl benzene. Benzene is acting as benzene we are taking as suffix, and ethyl group we are taking as a prefix. Ethyl benzene. If it is methyl group is there, we call it as methyl benzene. If it is chlorine, chlorobenzene. If it is bromine, bromobenzene. If it is propyl group, isopropyl benzene. Here we have one substituent alkyl group, that is a substituent, that is tertiary butyl group is there, and benzene. This is tertiary butyl benzene, or simply butyl benzene. So benzene, when it is having only one substituent, we call as alkyl group as a prefix and benzene as suffix. So many monosubstitute benzenes have common names. So what are the common names we have? If you take example of methyl benzene is commonly called as toluene, and if it is hydroxybenzene, we call it as phenol. If it is aminobenzene, we call it as aniline. If it is methoxybenzene, we call it as anisole. So there are so many derivatives which is having common names. So they are also called as, they can also name as common names, that is toluene, phenol, aniline, anisole, cresol, like. So it can be called as common names. So if the benzene, we know that benzene is having, when you go for dye substitution, two substances are present on the benzene, there is a possibility of getting three isomers. If you take example of benzene having two bromine groups, the first bromine group is a position at first position, and second bromine, there is a chance of attaching at second position, third position, and fourth position. So do all the three are isomers. So disubstituent molecules will have three isomers produced, that is orthoisomer, meta-isomer, and para-isomer. So orthoisomer we call it as 1,2 disubstituted benzene. Meta-isomer we call it as 1,3 disubstituted benzene, or para-isomer we call it as 1,4 disubstituted benzene. All are disubstituted benzenes only, but they differ in the position of bromine. First orthoisomer you have at 1 and 2, meta isomer you have bromine at 1 and 3, para isomer you have bromine at 1 and 4. That is reason orthoisomer we called as ortho dibromobenzene, or ortho O dibromobenzene, or 1,2 dibromobenzene. Similarly, meta isomer we called as meta dibromobenzene, or meta dibromobenzene, or meta 1,3 dibromobenzene. Para isomer, where the position of bromine are at 1 and 4 position, so it is para dibromobenzene, or 1,4 dibromobenzene. So the isomers are having different names only because of relative position of substituents. If the two groups on the benzene are different, for example, if you have bromine and chlorine, if you have nitro or fluorine, so the name of the benzene is name of the substance should be according to the alphabetical order, and the word suffix should be benzene. So if we take example of this molecule having bromine and chlorine at 1 and 2 position, bromine is having alphabet of B, and chlorine is having alphabet of C. So bromine B comes first, and chlorine comes next. So we call it as ortho-bromo-chlorobenzene. So one more example, the benzene is having two substituents, that is nitro group and a fluorine group. So nitro and fluorine comes first. So meta-fluoro-nitrobenzene. So whenever you have disubstituents, so we need to name according to the alphabetical order. The substance should be sorted out according to alphabetical order, and then benzene. There is another type of nomenclature. Out of two substituents, one substituent may be forming a common name, and other substituent will be acting as other substituent will act as a substituent. So if one substituent is a part of common root, name the molecule of the derivative as that of monosubstituent derivative. If we take the example of this molecule, this benzene is having two substituents. One is bromine group and it is methyl group. We know that methyl with benzene we call it as a toluene. So this forms a toluene molecule, and bromine is acting as a substituent. Bromine position is at the para position, so we call it as para-bromo-toluene. If the bromine is at an ortho position, we call it as ortho-bromo-toluene. If it is at meta position, we call it as meta-bromo-toluene. Another example, if you see in this example, this benzene is having two substituents. One is hydroxy group, another one is nitro group. We know that benzene with hydroxy group is having a common name, that is phenol, and nitro acting as a substituent. So nitrophenol is the name of the molecule. The position of nitro group also decides. If the nitro group is present at the ortho position, we call as orthonitrophenol. If it is at meta position, we call it as meta-nitrophenol. If it is para position, we call it as para-nitrophenol. So if we have more substituents, three or more substituents on the benzene ring, then we need to give the possibility, we need to number it such that the sum of the numbers should be least possible number. So numbering should be done such that the least possible number should be taken place. So number to give the least possible numbers around the ring, and try to assign the names according to the alphabetical order, then name it. So if you take the example of polysubstitute derivative here in this structure, the benzene is having substituents called as ethyl group, propyl group, and chlorine group. So we need to start. You should decide now. We should give first preference to chlorine or alkyl group. Alkyl groups are given highest priority than that of chlorine. Alkanes are given highest priority than that of chlorine. So numbering should always start from alkyl group. So if I take preference for alkane group here, so I can start from here 1, 2, 3, 4, 5, 6. The numbering count goes high. So I will take this carbon, the ethyl group as number 1, 1, 2, 3, 4, such that the ethyl group is having first preference, first number, propyl group is having second number, and chlorine group is having the fourth number. So this is getting the least possible number. So I prefer assigning the lowest possible numbers. So when you assign this, then you name the benzene according to the alphabetical order. So this is ethyl, this is propyl, and this is chloro. When you see here, chlorine is given highest alphabet first preference. This is 4 chloro, 1 ethyl, and 2 propyl benzene, because benzene is acting as a suffix and substituents are acting as a prefix. So 4 chloro, 1 ethyl, and 2 propyl benzene. Similarly, if it is a common name, if any of the substance is forming a common name, then you can make that as a common name. For example, if you see this molecule, amino group is with benzene, it is forming aniline common name. So other chlorine substance will be given highest priority. So numbering always should start from aniline amino group. Then anyways, if you consider amino group and chlorine group, amino group is at highest priority. We should start giving amino group as a first number 1, and the next number should be least possible. Here you have chlorine substituent, here you do not have substituent. I should not go from this side, I should go from this side. So chlorine given high to give least possible number 2, and next 3, 4, and 5th position you have one more chlorine. So it is aniline molecule. At 2 position and 5 position you have chlorine 2 molecules. It is 2 chloro, dichloro, 2, 5 dichloro aniline. So like this you can name the molecule. Even if the benzene, if you take the benzene is acting as substituent, if benzene is acting as substituent, we need to call it as a phenyl. Like methyl group, methane, when methane it is losing hydrogen, we call it as methyl. When ethane is losing hydrogen, we call it as ethyl. Similarly, benzene, when it loses hydrogen, the substituent we call it as phenyl group, it is abbreviated as PH. So phenyl is formed by the loss of one hydrogen from benzene. C6H6 is losing hydrogen to come from to C6H5. So phenyl. Therefore, benzene can also be represented as PHH. So phenol can be represented as PHOH. So if you see, there is PHH and PHOH, phenol or benzene. So here you need to name some more other compounds, like if benzene is phenyl group is attached having extra methyl group, the benzyl group, that is called as benzyl. If phenyl is attached to one extra methyl group here, see this is phenyl, and if you have one extra methyl group, the total group is called as benzyl. C6H5CH2 is called as benzyl. So C6H5 is called as phenyl, C6H5CH2 is called benzyl. If the CH2 is replaced with of C double bond O, we call as benzoyl. For example, benzoyl chloride, C6H5C double bond O Cl, that is benzoyl chloride. If C6H5CH2Cl is benzyl chloride. So you need to remember C6H5 is nothing but phenyl, C6H5CH2 is benzyl, and C6H5C double bond O is called benzoyl. So substituents derived from other substitute aromatic rings are also called as aryl groups. So this part we call as aryl group, tolulyl group, or this part we call as aryl groups. So if you take the IUPAC names of these molecules, we'll try to sort some questions here. So this phenyl group is attached to CH and CH3 twice. This part we call as isopropyl group is attached to phenyl group. Then we called as isopropyl benzene. It is isopropyl benzene. If we have one more CH3 here, means if it is CH3 thrice, then it is called as tertiary butyl benzene. Tertiary butyl benzene. If it is only one CH3, it is ethyl benzene. If it is two, isopropyl benzene. If it is three, tertiary butyl benzene. So what is the name of this molecule? How can you name this molecule? We know that it is a phenol, and at meta position you have 1, 2, 3, 4 butyl group is there. So it is meta-butyl phenol. What is this molecule name? And if it is see halogens and methyl group, which should be given highest preference? Methyl group is alkyl group should be given highest preference. So numbering should start from here 1, and I can number like this because chlorine is getting third. Here bromine is getting 2, so I'll go like this. So 1 for the methyl group, 2 for the bromine, 3, 4, 5 for the chlorine. So it is a toluene group, and 2 bromo, 5 chloro, toluene. So identify the name of the structures. How do you name this molecule? So it is benzene, and you can name from here 1, 2, 3. At 1 position and 3 position you have chlorine. So it is called 1, 3 dichlorobenzene. So when you see this molecule, chlorine and bromine is there. So you need to take the first preference, that is bromine. So bromo chlorobenzene. Bromo, ortho-bromo-chlorobenzene, or 2-bromo-chlorobenzene. It is ortho-dichlorobenzene. C is ortho-dichlorobenzene, and D we call as 1, 4 dichlorobenzene, or para-dichlorobenzene. So these are the names of the different molecules. So when you go in deep, we need to name these molecules. So methyl groups, ethyl group is there, and the ethyl group is attached at the ortho position each other, and we need to start numbering. So if I start numbering from this carbon, chlorine will get 3, or ethyl will get 2. So instead, we need to get the number such that the least possible number should be formed. So I start from here 1, 2, 3, 4. Chlorine is assigned 4, ethyl group is attached 2, and ethyl group is attached 1. So 2 ethyl groups are there. So 1, 2 diethyl benzene. So substituent will be 4 chloro. 4 chloro, 1 ethyl, 1, 2 diethyl benzene. So if you see here, I can start numbering from either here or here. 1, 2, 3. So chlorine is assigned as second carbon, and 1 and 3 position you have ethyl groups. So 2 chloro, 1, 3 diethyl benzene. So C, how do you name this? It is a ethyl benzene. So 2 chloro ethyl benzene. And D, it is I should start numbering from here 1, 2, 3, 4, 4 chloro, 1, 3 diethyl benzene. This is how we need to name the benzene structures. So in the summary, what we have discussed is we have seen the different oxidation reactions, addition reactions of benzene. Benzene react with halogen to give BHC, that is gemaxine. Benzene react with hydrogen to give cyclohexane. It undergoes oxidation reaction also. When it undergoes oxidation reaction, it gives rise to glyazole, or it gives rise to maleic anhydride. Addition reaction, it follows free radical mechanism. Oxidation reaction, when it is reacted with oxone, it forms glyazole. When it is reacted with vapor phase oxidation in the presence of catalyst, it gives rise to maleic anhydride. And we have named the benzene derivatives. For mono substrate derivatives, we need to add the substituent as prefix and benzene as suffix. If it is disubstituent, we need to use the positions of the position of the substituent and suffix benzene. If it is two different disubstitute benzenes, then we need to count according to the alphabetical order. If 3 substituents are more, then we need to number the benzene structures according to the priority and least possible numbering, and we need to follow the alphabetical order such that we need to name the molecule. So this ends your class, and in the next class we will discuss about the effect of substituents on reactivity and orientation of different molecules, different benzene derivatives. Thank you.